Hello, everyone. Welcome to Math 60. This video lecture is section 4.2, solving systems of equations symbolically using a method called substitution. So the first thing I want to say is, if you want to graph it, if you want to graph the system, go ahead. We have the tools. Let's use the tools. You never have to, at least not in my class, you never have to solve a system of equations symbolically. You are welcome to always solve it graphically. However, the ideas of substitution are useful in a lot of areas, and so it's worth practicing these ideas in kind of the initial use for them, which is solving systems of equations. And basically, we're going to follow a recipe. So suppose I want to solve the system. I'm going to start with that same one I had last time, x plus y equals 3 and x minus y equals 1. And I want to solve this without graphing. I'm going to follow these steps. Step 1 is identify the equation that looks easier to solve. Looks easier to solve for one of the variables. We're not going to be able to figure out what that variable number is, but we can at least isolate it. So easier to solve for one of the variables. This means isolating that variable. Now with this example, they're both pretty easy, but I'm going to choose to work on the second equation. I'm going to choose the x minus y equals 1 because if I add y to both sides, I have isolated the x, and it was very simple to do that. I have now isolated x. And this equation, I'm going to put a star next to it. The starred equation is the piece of information that we're going to use in our first equation. So step 2, substitute, and this is why it's called substitution, substitute the starred equation into the other original equation. Replacing the isolated variable. In this example, the isolated variable is x. So I'm going to take my other equation, which is x plus y equals 3, and every time I see an x, I'm going to use the starred equation, x equals 1 plus y. So instead of x, I write what x equals in terms of the starred equation. And now step 3 is solve this new equation for the remaining variable. And when I say this, I hope that you notice this new equation only has a single variable, which means I can solve it. By substituting, I have gotten rid of the two variable equation and I have turned it into a single variable equation. And single variable equations, we have the tools to solve. 1 plus y equals 3. Well, that's just 1 plus y, which is 1 plus 2y equals 3. And so I'm going to solve 1 plus 2y equals 3. I subtract 1 from both sides. I get 2y equals 2. I divide both sides by 2, and I get y equals 1. And now I have found my first variable. I have a number. I know that in my solution, y has to equal 1. And the last step is to return to the starred equation to find out the missing variable. Step 4, use the starred equation to find the second or the missing variable. My starred equation tells me if I know y, I can find x. In my example, my starred equation was x equals 1 plus y, and I know that y equals 1. So x equals 1 plus 1, x equals 2. So my solution, written as usual as a coordinate point, x equals 2, y equals 1. Those are the 4 steps. You're given a system of equations. In this class, it's usually going to be 2 equations, but there's no reason why it couldn't be more than 2. Your first step is to identify a simpler equation and solve it for one of the variables. Give that expression a star. Use that expression in your other original equation to turn it into something with only a single letter, a single variable, which you then solve. And then you use that solution in your start equation to get the second variable. Let's do it again. Just a couple more practice can help. Let's solve x minus 3y equals, I'm just making this up, x minus 3y equals 13. And x divided by 4 plus 2y equals 9. Now, we have a choice when we do our step 1. We can pick not only which equation we want to work with, we can also pick which variable we want to work with. So I could choose the first equation and solve for x, or solve for y. Or I could pick the second equation and solve for x, or solve for y. So you have to make a decision. There's not a wrong decision, but there's an easier decision and a harder decision. If I picked my second equation, I think it might be a little trickier when solving. So I'm going to pick my first equation. I'm going to solve the x minus 3y equals 13. And now I also get to pick which variable I want. Well, I could solve for y, but that's going to be dividing by 3. So in fact, I'm going to solve for x this time. And to do that, I add 3y to both sides, and I get x equals 13 plus 3y. That's my starred equation. My next step is to use this start equation in my other original equation. So my x over 4 plus 2y equals 9 becomes x, which is 13 plus 3y over 4, then plus 2y equals 9. Not the nicest looking equation, but at least it's just a single variable. Now I'm going to solve this new equation. I'm going to solve 13 plus 3y over 4 plus 2y equals 9. I'm going to solve it for y. And first, I'm going to see the other thing about this chapter is we're going to come back to a lot of skills you've been working on. And one of the skills is what do you do when you have a denominator and you don't want it? You can multiply everything by that denominator and clear things out. So I can multiply my first term and my second term, and the other side, I can multiply them all by y, or by 4, excuse me. I can multiply them all by 4, and that's going to clear that denominator, and I get 13 plus 3y plus 8y equals 36. We've also worked on collecting like terms. So let's collect those like terms. 13 plus 11y equals 36. Solve for y, so subtract 13 from both sides. And I get 11y equals 23. Divide both sides by 11. And I have y equals 23 over 11. Not an integer, that's a fraction, but it's still a number, so I'll work with it. I found one piece of my solution. And so let's see, that all was step 3. And step 4 is to use that solution in my starred equation, x equals 13 plus 3y. And I know what y is, so x must equal 13 plus 3 times 23 over 11. All numbers on the right side, so I just have to kind of multiply it all out. X equals 13 plus 69 over 11. We've worked on adding fractions. Remember, we need them to have the same denominator, so let me multiply the 13 by 11 over 11. And then I have the 69 over 11. That's 143 plus 69 over 11. And that tells me that my x value should be, let's see, 212. 212 over 11. I'm not really sure if that reduces. It does not. So I'm done. So my solution, x comma y, is 212 over 11 comma 23 over 11. And I'm done. All right, let's do another example. Let's look at that example where Joe, who catches a football, Joe's distance from the end line or the end zone is 50 minus 5x, and Fanny, who is chasing Joe, has y equals 70 minus 8x. And we want to find out when Fanny catches Joe and if that happens before Joe reaches the end zone. So we're being asked to solve the system y equals 50 minus 5x and y equals 70 minus 8x. And notice that in step 1, which asks us to pick an equation and solve it for one of the variables, both of my equations are actually solved for one of those variables. So I can pick either one and it's already my starred equation. Step 2 will be to substitute this into my other equation. So y, which is 70 minus 80x, the y is the 50 minus 5x. So 50 minus 5x equals 70 minus 8x. And again, that makes sense because this is Joe's distance and this is Fanny's distance, and we want them to be the same. That's what it would mean for Fanny to catch Joe. So in this case, the first couple pieces are very simple. We already have our starred equation, and substituting it in is as simple as making these two pieces equal each other. And so now we'll solve. And this is an exercise in collecting like terms. 50 minus 5x equals 70 minus 8x. Let's add 8x to both sides. And we get 50 plus 3x equals 70. Now we'll subtract 50 from both sides, and we get 3x equals 20. Divide both sides by 3, and we get x equals 20 thirds, which is that 6.67 more or less. And then step 4 is to grab this and put it back into our original starred equation. So I have y equals 50 minus 5x, and I know that x is 6.67, or I could write it as 20 thirds. I'll write it this way. Use my calculator to find out what 50 or 5 times 6.67 equals. It's going to be 34.33. So when I do that subtraction, I get y equals 16.67. And so x comma y is 6.67 comma 16.67. And to put it in context, Fanny catches Joe. Fanny catches Joe after 6.67 seconds, 16.6 yards from the end zone. All right. So it is possible, just like with the graphical solutions, to have zero or infinite solutions, and to discover this fact using substitutions. So let's do an example of each. Let's solve, let's do 3x plus 2y equals 10. And let's do y equals negative 2/3 x, negative 3/2 x plus 5. So step 1, find an equation that's easy to solve for y. Well, we've got one. It's already solved for y, or solved for x. But here we have one that's already solved for y, so that's going to be my starred equation. And step 2, we're going to substitute it into my other original equation. So 3x plus 2y equals 10 becomes 3x plus 2 times the quantity negative 3/2 x plus 5, and that all still equals 10. And now we're going to solve that equation. Solve 3x plus 2 times negative 3/2 x plus 5 equals 10 for the remaining variable, which is x. Let's distribute the 2. And we have 3x minus 3x plus 10 equals 10. And when we collect like terms, I end up with 10 equals 10. This is always true. Doesn't matter what x and y equal. If x is 1,000,000 and y is negative 5, 10 still equals 10. So I have infinite solutions. And the best I can do is I can say x can be any number, and y equals the starred equation. So when you have infinite solutions, you get to pick any value for your first variable, and then your second variable is the starred equation, which is solved like so. Okay, let's try something a little different. let's do as an example. Let's solve 4x minus 5y equals 12. And let's see, 10y equals 8x plus 12. I think that's going to build something useful for me. Okay, so step one is pick one of these equations and solve it for one of your variables. I think it'd be fairly straightforward to solve my second equation for y. So I'm going to do 10y equals 8x plus 12. Solving for y means dividing everything by 10. And you have y equals 8/10 or 4/5 x plus 6/5. 12 over 10 is 6/5. That's my start equation. Step two, put that start equation into my other 4x minus 5y equals 12 becomes 4x minus 5 times the quantity 4/5 x plus 6/5. And all of that should equal 12. Step three, solve it. And so my first step is going to be to distribute this minus 5. So I'm going to get 4x and then a minus 4x and then a minus 30 because, oh, sorry, minus 6 because negative 5 times 6/5 is negative 6. And that's supposed to equal 12, but those terms cancel, the x terms cancel, and I'm left trying to claim that negative 6 equals 12. This is never true. It doesn't matter what x and y I pick. Negative 6 will never equal 12, so there are no solutions. And if you were to put both of these equations into a graphing calculator, into Desmos, you would see that they look something like this. That they are parallel, they have the same slope, but different y-intercepts, and therefore there are no solutions. Now, just coming back to what I said at the very beginning, if you ask me what's easier, doing the symbolic approach or just putting them into a graphing calculator, I recommend you use Desmos. It's quick, it's accurate, it's easy. The skill here is recognizing even when I have complicated systems, by picking a series of methodical steps and following those steps, I can break it down into something simpler. And that's really the skill with solving these systems by hand, is learning how you can take complicated systems and take them one step at a time in order to make the process simpler. All right, our last video will look very briefly at another way to solve systems of equations. And thanks for watching.